Good afternoon, everyone. Today we're going to graph a reciprocal linear function. So we're going to graph y is equal to 1 over 2x minus 6. So first things first is I advise my students to find their vertical asymptotes. So the vertical asymptotes are always the x values that make our denominator be 0, right, which would make our function be undefined. And so that means that we're going to make an equation out of our denominator, 2x minus 6, being equal to 0. That's easy enough to solve. Right, 2x is equal to 6, and so x is equal to 3. And this actually serves as the equation of our vertical asymptote. And so this is like a vertical barrier with equation x is equal to 3, where no points on our function can lie. Okay. Now we have invariant points. Our invariant points are the points that would not vary if we graphed just 2x minus 6 rather than its reciprocal, right? And that's going to be the case when 2x minus 6 is equal to 1 over 2x minus 6, right? But if we ask ourselves, when is that going to be the case? Well, that's going to be the case if 2x minus 6 is equal to 1, because then in which case we would have 1 is equal to 1 over 1. Or the other way that could happen is if 2x minus 6 was equal to negative 1, right? Because then again, if 2x minus 6 was equal to negative 1, then we would have negative 1 is equal to 1 over 2x minus 6 was negative 1 over negative 1. Because that is certainly the case that negative 1 is always equal to 1. Goodness gracious. Negative 1 is always equal to positive 1 divided by negative 1. Those are the only values for which that's true, right? There's nothing else where that is true, right? We're really solving the equation x is equal to 1 over x, right? Except instead of just x, we're looking at more complicated functions. But solving this equation would mean that multiplying both sides by x, that x squared would be equal to 1, and then square rooting both sides, we would get that x is positive or negative 1. So that's why we have two options for solving this equation. Otherwise, we could multiply both sides by 2x minus 6, but now we're solving a more messy quadratic equation, which is just a bit more work. So if we take the time to think this through, we only have to solve these two linear equations. A lot easier, right? If we look at the first one, that means x is 7 over 2. And if we look at the second one, add 6 to both sides, x is 5 over 2. So that's 3.5 and 2.5 for the x coordinates of our invariant points. And if 2x minus 6 is equal to 1, then that means that our reciprocal function is 1 over that, right? And so 1 over 1 is 1. So when x is 3.5, we're going to have a y coordinate of 1 over 1, which is 1. And so 3.5, let's use the blue marker, 3.5 and 1, it's roughly here. And when x is 2.5, 5 divided by 2, our 2x minus 6 is going to be equal to negative 1. And so y is 1 over negative 1, right? 1 over 2x minus 6, which we said had a value of negative 1 in this case. So 1 over negative 1 is negative 1. So when x is 2.5, y is negative 1. That takes us around here, okay? And now after that, we know the general shape of 1 over a linear function, right? It's that boomerang shape and that boomerang shape around the vertical asymptote. And so we can go ahead and sketch it. One other point we can get that is typically of interest is our y-intercept. Anytime we want a y-intercept, we set x equal to 0. So that would make y be equal to 1 over 2 times 0 minus 6, right? Plugging in 0 in for x, which would make it that 1 over negative 6, which is negative 0.17 roughly, right? So that means our y-intercept would be roughly around there. That's just enough to consolidate the idea that this bottom half of our reciprocal function is going to look like so, the same way it typically does. And then the top right side will look like this. Okay. So we have our vertical asymptote along the line x equals 3. We also have our horizontal asymptote along the line y is equal to 0. And that can be the last piece of information. Our horizontal asymptote is y is equal to 0. That's because the limit as the x values go towards the infinities, namely the limit as x goes to positive or to negative infinity, i.e. far to the left or far to the right, of this function of 1 over 2x minus 6. As x gets really, really, really big, either positive or negative, this gets closer and closer and closer to 0. And the ultimate limit of that, if x was infinity truly, would be 0, right? 1 over 2 times infinity would be 0 in theory. And so we say that's the limit, and that 0 is why we have a horizontal asymptote along the line y is equal to 0. And this would be our sketch. Okay, we don't have any x-intercepts because, again, we have a horizontal asymptote along the x-axis, so we have no x-intercepts, right? We have vertical asymptote as x equals 3. Again, vertical asymptotes stem from our denominator being 0. That would make our function undefined. That's precisely what a vertical asymptote is. It's a vertical line where the function is undefined, right? And then again, the invariant points come from, this is a reciprocal function, and so we can always look at the denominator itself being equal to 1 over itself, let's say. So this happens strictly when we have 1 is equal to 1 over 1, right? Because these two things have to be the exact same value. The only time all of this works out is if we have 1 is equal to 1 over 1 or negative 1 is equal to 1 over negative 1. And so we have two options for invariant points, and we can solve those for x. And then that gives us two nice, these hook points to kind of sketch the curvature of our graph. So I hope this helps put some pieces together, and thanks for watching.